Hi, this is Sunil Pandey, faculty of BC College of Pharmacy. I'm just working as an associate professor in BC College of Pharmacy. Today, just I'm going to explain about the Sikkim acid pathway because some students has told me that sir, there is a need of once again explanation by you because they were not present when I have just taken the class. So today I'm just going to explain about the Sikkim acid pathway. So Sikkim acid pathway, it is a metabolic pathway. It is a metabolic pathway. It is used by bacteria, fungi, and plants for the biosynthesis of aromatic amino acid. If we are discussing about the aromatic amino acid like tryptophan, tyrosine, and phenylalanine, these are the aromatic amino acid which is just made from the metabolic pathway which is occurring in plant, bacteria, fungi. By this way, we can just make these secondary, you can say the aromatic amino acids. This is not the secondary plant metabolite because this is the primary metabolites, and the secondary metabolites are just manufactured, you can say the synthesized from these amino acids, aromatic amino acids like tryptophan, tyrosine, and phenylalanine. Now, just I'm going to explain how the cyclic acid pathway run. So, if we are discussing about the cyclic acid pathway, then first of all, we will discuss about the pentose phosphate pathway. This is also called HMP shunt, and by using this pathway we can synthesize the erythrose 4 phosphates, and their structure is CHO, CHOH, CHOH, CS2OP. This is the erythrose 4 phosphate. This compound is obtained from the pentose phosphate pathway, which is started by using the carbohydrate like glucose. Then this is the phosphoenol pyruvate, CS2, COP, and COH. This is, in short, you can say the PEP, and its full form is phosphoenol pyruvate. This is obtained from the glycolysis, which is started from the glucose, and this is the product of glycolysis, PEP, phosphoenol pyruvate. These two compounds, this is the erythrose 4 phosphate and the second one is the phosphoenol pyruvate. These two compounds are required for running the cyclic acid pathway. Cyclic acid pathway. These two compounds are working as a precursor for starting the cyclic acid pathway. I think you understood what I have told you. Then erythrose 4 phosphates, erythrose 4 phosphate plus PEP by using the enzyme DAHP synthase, and there is a formation of 2 keto 3 deoxy 7 phospho D glucohaptonic acid. The compound, that is the erythrose 4 phosphates, which is obtained by HMP stunts, and the second compound, that is the phosphoenol pyruvate. In short, we can say the PEP. This is obtained by the glycolysis. In presence of DHP synthase enzyme, there is a 2-keto 3-deoxy 7-phospho D-glucohaptonic acid is formed. Then there is a cyclization by using the enzyme 3-dehydrogenate synthase. What enzyme we have used? We have used 3-dehydrogenate synthase. This is the enzyme which is used for the cyclization of 2-keto 3-deoxy 7-phospho D-glucose haptonic acids. By using this enzyme, there is a cyclization compound cyclic compound is formed. Before going to make the cyclic structure, now just going to make 2-keto 3-deoxy 7-phospho D-glucohaptonic acid. Haptonic acid. If you are going to make the structure, then you can see what is just happening. That is CHO, CHOH, CHOH, CS2OP. This is erythrose 4 phosphate, which is obtained by pentose phosphate pathway. And the second compound, that is the CS2 double bond COP COOH, that is PEP, phosphoenol pyruvate, which is obtained by the glycolysis. Then there is an enzyme DAHP synthase, and there is a condensation reaction is taken place. Now the compound is COOH, C double bond O, CH2, CHOH, then COH, then CHOH, then CS2OP. This is 2-keto 3-deoxy 7-phospho D-glucohaptonic acid, which is formed by the condensation of erythrose 4 phosphates and phosphoenol pyruvate by the presence of, you can say, in presence of DHP synthase enzyme. Now I have already told you, and this compound is go for the cyclization reaction in presence of enzyme 3-dehydrogenate. That is the enzyme. That is the enzyme 3-dehydrogenate synthase. And this compound go for the cyclization. After cyclization, there is a formation of three dehydroquinic acid, and this is the structure of 3-hydroquinic acid, that is COOH, HO, C double bond O, OH and OH. This is the 3-hydrochloric acid, which is formed after the cyclization of 2-keto 3-deoxy 7-phospho D-glucoheptonic acid. Now there is a removal of water molecules. After removing of water molecules, there is another compound is formed, that is COOH, C double bond O, OH and OH. What is happening? Just there is a movement of this atom and 3-dehydro Skp acid is formed. After removing of water molecules, there is a new compound, that is a 3-dehydro Skp acid is formed. Now there is a new compound, that is the Skp acid, and this is the structure of Skp acid: COOH, OH, OH and OH. This is the Skp acid. That is the Skp acid. That is the Skp acid. That is the Skp acid is formed from from 3-dehydroskimic acid. This Skp acid is formed from 3-dehydroskimic acid by using the enzyme Skimate dehydrogenase. By using the enzyme Skimate dehydrogenase. Skimate dehydrogenase. This is the enzyme which is used in the formation of Skimic acid from the 3-dehydroskimic acid. Now, what is happening? This is the Skimic acids. This is a Skimic acid. From this Skimic acid, now I am going to just make new Skimic acid, by which we can understand very well. This is COH, OH, OH and OH. This is Skimic acid. Skimic acid. By using an enzyme Skimate kinase, and other compound is formed, and their structure is COOH, OH, OH, O and P. What is happening in this structure? There is a phosphorylation. One P molecules, one phosphate atom is attached from this oxygen atom. When we are using the Skimate kinase as an enzyme on Skimic acid, and this compound is known as Skimic acid 3-phosphate. This compound is Skimic acid 3-phosphate. Then what is happening? This Skimic acid 3-phosphate be at PEP, that is a phosphoenol pyruvate. Then a new structure is formed, that is we are going to make COH, that is O, that is P, OH O C CS2 COOH. This is the PEP molecules which add in cyclamic acid 3 phosphates, and this compound is known as 3-enol pyruvyl cyclamic acid 5 phosphate. After using the adding the PEP phosphoenol pyruvate in cyclamic acid 3 phosphate, we will get 3-enol pyruvate cyclamic acid 5 phosphate. And what is next happening? Now this compound go for next reaction. We are using chorismate synthesis on this compound, chorismate CHO, chorismate synthesis. Chorismate synthesis. This is enzyme which is used on 3-enol pyruvate cyclamic acid 5 phosphate. After using this enzyme, we will get a new product, that is the chorismic acid. We are going just make OH O COOH double bond CS2 and COOH. This is chorismic acid. Chorismic acid. This is chorismic acid. And from this chorismic acids, another compound is formed, that is prephenic acids. Prephenic acids. This is the structure of prephenic acids. HOOC and CS2 C double bond O COOH. But during this reaction, there is a need of an enzyme, that is chorismate mutase. This is the enzyme which are used for the formation of prephenic acid. This is prephenic acid. HO. This is prephenic acid. Prephenic acids. Now, this prephenic acids play an important role for making aromatic amino acids. Now, this prephenic acids is go for two new steps, that is when we are using prephenate dehydratase enzyme prephenate dehydratase. When we are using this enzyme, then we will get a new compound from prephenic acid, that is phenylpyruvic acid. That is phenylpyruvic acids. The structure is CH2 C double bond O, COOH. This is phenyl pyruvic acids. Phenyl pyruvic acid. And this phenyl pyruvic acids make our aromatic amino acid, that is phenylalanine, and the structure is CH2 CH NH2 COH, that is phenylalanine. And in between these reaction, there is a need of an enzyme, that is a phenylalanine aminotransferase. That is phenyl that is phenylalanine amino transferase. Phenylalanine aminotransferase. This is the enzyme which are used by the phenyl pyruvic acid, and from this compound, with the help of phenylalanine amino acid, we will get the aromatic amino acid phenylalanine. And the second step is, we will get one aromatic amino acid, that is the phenylalanine. Now prophenic acids, when we use the prophenate dehydrogenase, another enzyme, prophenate dehydrogenase, this another enzyme. In previous reaction we have used the prophenate dehydrogenase, and this we will get at the time phenylalanine, that was the aromatic amino acids. Now when we are just using the prophenate dehydrogenase, this enzyme, on prophenic acid, then we will get a new compound, that is the 4-hydroxyl phenyl pyruvic acids. We are going to make this structure of 4-hydroxyl phenyl pyruvic acid, CH2 C double bond O, CH2 C double bond O, and COH and OH. This compound is 4-hydroxyl phenyl pyruvic acid. This compound is 4-hydroxyl phenyl pyruvic acid. And on this compound we will use tyrosine amino transferase, and we will get our second aromatic amino acid, that is tyrosine, CH2 NH2 COOH, CH2 NH2 COOH. This is the tyrosine. This is the second aromatic amino acids, OH. Then if you want, I can just make more clear. And you know that when we are using the prophenate dehydrogenase, this is the enzyme we are using on prophenic acids, then we will get a new compound, that is a 4-hydroxyl phenyl pyruvic acid. When tyrosine aminotransferase, this is the enzyme when you use on 4-hydroxyl phenyl pyruvic acid, then we will get our aromatic amino acid, that is the tyrosine, and this is the structure of tyrosine. OH and CS2, CH, NH2 and COH. This is the tyrosine. Tyrosine. And this way we will make tyrosine and phenylalanine. And when just we are using this pathway, we have got one compound, that is choristmic acids. If you remember, when we are using chorismate synthesis on compound 3-enol pyruvyl Skp acid 5-phosphate, just I am going to make, this is the compound, double bond CS2, COOH, O and P. This is the 3-enol pyruvyl Skp acid 5-phosphate. This is the compound. This was formed when we have used the erythrose 4-phosphate, that was that comes out from the HMP salts, and we have used the PP, that is the phosphoenol pyruvate, from the glycolysis. Then after the aldol condensation, and we have used different type of enzyme, then we have got the this product, that is a 3-enol pyruvyl Skp acid 5-phosphate. On this compound we have used one enzyme, that is the chorismate synthase. This is the enzyme, and when we have used this enzyme, then we have got the chorismic acids, and this is the structure of chorismic acid. OH, O, double bond CS2, COH and COOH. This is the chorismic acids. Chorismic acids. And on this chorismic acids, we will use an enzyme, and this enzyme is known as anthranylic acid synthase. Anthranylic acid synthase. This is the enzyme, and one compound is formed. One compound is formed, and the compound is known as anthranylic acids. NH2. Its name is anthranylic acid. This is anthranylic acids, and from this anthranylic acids, our next aromatic amino acid, that is tryptophan, is formed, and their structure is NH2 COOH. This is tryptophan. Okay, by this way there is a 3 aromatic amino acid, that is a tryptophan aromatic amino acid, this is, and tyrosine and phenylalanine. These 3 aromatic amino acid is formed from the Skp acid pathway, and this is the primary metabolites, and from these metabolites we can just you can say the plant just make the secondary metabolites like alkaloid, glycoside, terpenoid, tannin. These are the secondary metabolites which are just formed from the primary metabolites. And I have already told you that the primary metabolites just plant use for the growth, reproduction and their development, and the plant secondary metabolites just used for the defense mechanism, and the animal or human being just use these secondary plant metabolites for their uh, as a medicinal property. You can say that for the pharmacological action, and in plant this is used for the as a production property. You can say defense mechanism, for the defense mechanism. So plant just use these two metabolites for different purpose. First, primary metabolites is used for the growth purpose, or you can say the their development, reproductive purpose, and secondary metabolites is used for the defense purpose. So you can just practice, and definitely you will be able to make these Skp acid pathway, because it is very important, and definitely you will get these Skp acid pathway in examination. Thank you.